Hello, my name is Slavik Neimer and I'm a Principal Software Engineering Manager at Microsoft. Today, I'm going to show you how to get started with KQL. Let's start with this screen. Here you can see the list of tables in the database and also the details about the selected table, like the number of records, the person who last ingested the data, the size of data, compressed and uncompressed, and the compression ratio, and also the schema, which is the columns. For each column, you can see the name and the type. Now, if I click on this context menu, I can run one of the predefined queries. For example, let's see the total count of records. All I have to do is click here, and I get the query. When I run it, I see the total number of records. I can try some other queries from here in KQL, but we also have a couple of SQL examples, like take any 100 records. Here I run it, and I get 100 records, as you can see. Now, suppose you already know SQL and you want to see how to write this query in KQL, Custom Query Language. All you have to do is write the explain word here and run the query. Here you go. What you see here is log benchmark, pipe, project, and the list of columns, pipe, take 100. Now, the list of columns is actually redundant here because we could completely omit the project operator. But if you use this query, you can actually remove some of the columns and it will work just fine. So it helps you learn KQL. It's a really good idea to try the explain command. And now let's switch to a KQL query set that I have already created. First of all, I strongly recommend that you read these two documents. The first one is a KQL reference guide, and the second one is a guide that helps you convert SQL queries into KQL queries. KQL stands for Custom Query Language. Count the number of records in the logs benchmark table. All I have to do is write the table's name here, followed by pipe and the count operator. In KQL, a pipe is used to pass data from whatever comes before the pipe into the operator that comes after it, in this case, count. Now let's look at some arbitrary 10 records in the table. The way I do it is I take the logs benchmark table, I use the pipe, and the take operator. As you can see, we have multiple columns here. We have a timestamp column of type datetime. We have the source, which represents some cluster name. In every cluster, there are multiple nodes. For example, you can see that for this cluster, there are multiple nodes, right? Every trace has some level. We have information, warning, and you'll see that we also have some others. The component name that produced this trace, client request ID, which is a unique identifier for the user's operation, a message, which is a string, free text, and we also have the properties column, which is empty for these records, except one, but we'll get to it after. Let's look at the timestamp column and find the minimum value and the maximum value in this column. The way we do it is we use the summarize operator, which takes the timestamp column and calculates the min and max values for it. Let's run the query. Here you can see the result. As you can see in the result, all the traces are from the same day. Let's look how many traces we have per level. The way we do it is we use the summarize operator again, this time with a by. What this does is for every level, it counts the amount of records. And we got a result saying that information is by far the most prominent level, which makes sense, and critical is the rarest one, which makes sense as well. Here I'm going to show you how to get traces from a specific client request ID. All you have to do is use the where operator, give it the column name, use a double equal sign, and provide the ID that you want to look for. Now note that sometimes throughout this demo, I'm going to use single quotes, sometimes I'm going to use double quotes. It doesn't really matter. Both are equivalent. Now let's count how many warning traces we have containing the word enabled in the message in a time frame of 12 hours after the beginning of this day. From this query, we got 99 million records. Now let's look for a rare term appearance. Let's filter by two columns. Level is error, and the message contains this word. Almost 8,000 records. As you remember, there is a component column in the trace. Now let's see if some components produce a much larger amount of error traces. What I do here is I filter the traces by the level. I count the amount of traces per component, and then I take the top 10 values in the count column. Now, after the name of the column, I can then say that I want it to be in descending order or ascending order. The default is descending. Now I want to get exactly the same result, but I want an additional column named percentage, indicating the percentage of this trace out of all error traces. How did I get this result? I used the previous query, except the top 10. I gave it a temporary name, t, and then I used the extend operator, which adds a new column named percentage. That is a concatenation of two things, the actual number and the percent sign. The actual percentage is counted like this. I look at t, which is this. I count the sum of all the values in the count underscore column, and then I use it to calculate the percentage. I also use the round function to leave only 2 digits after the floating point. And again, I take top 10 by count. Let's look at 10 arbitrary error records. Here is a filter by the level. I take arbitrary 10 records and I project only the message column. As you can see, all the error messages start with exception equals the type of the exception followed by a semicolon. What I can do now is I can look at all the error traces and parse the message column to look for exception equals. Whatever comes after will get into a new column named exception. And we stop at the first semicolon that we see and discard all the rest. We then do a summary count by exception and top 10. By the way, when you want to run a query, you can either click run here on the top left corner, or if you're like me and you like using the keyboard, you just press Shift Enter on your keyboard. And you can see that these 5 exceptions are by far the most frequent ones. Okay, now remember the properties column? Let's look at some records for which the properties column is not empty. If I scroll to the right, I will see that it contains a JSON. What I'm going to do is I'm going to look for traces from this specific component. I'm going to take this string, parse the JSON, and extract the format. You can see that for these records, it is per K. For some other records, it's CSV and per K again. What I do is I take the logs benchmark table, I filter by the component, and then I add a new column named format, the value of which will be the parsed JSON from which I extract the format value. And I convert it into a string because whenever I use the dot here, I actually get another JSON, which means that I can keep extracting the next key and the next key. But as soon as I stop, in this case format, I need to indicate that this value is actually a string. Then I use summarize count by format. What we're doing here is looking at billions of records, filtering by the component, and then parsing the string into a JSON, extract a certain field, and do a summarize. You can see that the distribution is pretty much uniform between all these four formats. Now we're going to do the same with another set of traces from the downloader component and extract the download duration as a time span and look at the sum by source. Then we're going to take the 5 highest values. Okay, we got the results. We can see that it's pretty much uniform. Now let's go back to the previous query, but instead of looking of how popular every format is in general, let's look at the cluster with the most ingestions. So what I'm going to do is I'm going to, first of all, find the source with the most ingestions. I'm going to do it by logs benchmark where component equals ingester executor, summarize count by source, top one by count, and then I'm going to leave the source. Just to demonstrate what I'm going to get here, it's this source. It doesn't really matter for the query. I just wanted to show you that you can select part of the query and run it. Note that this is a table with one record and one column. What I want to do is extract this into a string. So I'm going to use the toscalar function and store the result in a variable named source with most traces. We call this a let statement. A let statement must be followed by a semicolon. Then I write a new query, logs benchmark, where the source equals source with most traces, which is this one here. I then filter by the component, extract the format, and do a summarize by count. You can see that this specific source has more Avro ingestions than all other formats, even though it's still pretty much uniform. I can go on for ages explaining about the different operators and functions in KQL, but I hope it was a good start. Again, I strongly recommend that you read these two documents. They will give you tons of valuable information. Thank you very much for watching this.